Hello everyone, welcome back. Today is going to be our first week of our sauerkraut fermentation. So first thing I want to go over is calculating your aerobic plate count, APC. So according to BAM, we're going to be counting all the colony forming units that are within the 25 to 250 range. Those are going to be the ones that we're looking for. We're going to be trying to get them within that range. If we have more than 250, then it'll be TNTC, or too numerous to count. And if on the plate you had less than 25, then you're just going to record that number, but that's lower than the range that we want. But still make sure to record the number. So for spreading colonies, so you see a little streak there, you can just mark those plates as SPR. Okay? So if it's really severe, so just one of them like this is going to be 1 CFU, it's just going to be counted as one colony. But if it's a lot of spreading going on, then, so in this one, then that would just be SPR. Okay, so for calculating plate counts, we have a few very important rules according to BAM procedures. We're going to only count the 25 to 250 for calculations. Our duplicate is going to be averaged. So we have our two duplicate plates that we do for each dilution factor, and then we're going to average those two plates. Okay, so we got 40 on one, 47 on the other, so then the average of those two would be 43.5. But then we're only going to be doing two significant digits, okay? So two significant figures, and all of it in scientific notation. So our average is going to be 43.5 when you combine these two. And then we're going to round to 4.4 because we're only going to have two significant digits. So make sure to remember to put CFU per ml as a unit. Okay, CFU per ml. So when we're rounding off to the two significant digits, we have important rules that we need to follow according to BAM. So let's see if we can figure out the pattern from this. Okay, so we have 12,700 is going to round up to 13,000, two significant figures right here. Now 12,400, as we'd expect, 4 here, is going to round down. So now when we have a 5, it's always going to be rounding towards the even number, okay? So we have 15,500. Now, since it's a 5, the 5 would go up in order to make it even, 16. Whereas now we have 14.5 or 14,500. So we're going to be rounding down in order to keep this an even number. So it's going to be 14,000 in this case, okay? So keep that in mind. You're always going to be rounding towards the even number when you have a 5. So if it's below 5, then it's going to go down. If it's above 5, then it's going to go up. So our first set of rules for counting plates. So rule number 1, you're going to use a set of plates that fall within the countable range. Okay, so for this example, we have two different dilution factors, 10 to the negative 2 and 10 to the negative 3. So this 10 to the negative 2 falls outside of our range. It is above 250, whereas these two fall within our range, so we're going to be using these. So we add them together, and then we get our average. So 25 plus 35 is going to give you 60. Then you divide that by 2, will give you 30. And then since this is 10 to the negative 3, this is going to be 3.0 times 10 to the 4. So if only one of the duplicate plates yields 25 to 250 colonies, then you're going to be counting both plates and average the counts. So even though for this one, the 21 doesn't fall under the 25 to 250 range, but since one of those two at that dilution factor do, then you're going to be using it. So 21 and 35, add them together, then you get the average. Okay, so for this example, now our one that falls within the range, accountable range, is in the lower dilution, 10 to the negative 2. So when you get that average, you're just going to be using these two numbers. You don't use the other dilution factor, okay? Since there's none within the countable range, we don't use it. So it's just going to be based off this number. So for rule number 4, if consecutive dilutions yield at least one plate with 25 to 250 colonies, then you're going to be using all 4 of them. So you see all of these and all of these are within our countable range, so we're going to be using all 4 of the numbers. So we can figure this out. So 228 times 10 to the negative 2 is going to be giving you 22,800. And then here, this is going to be given 240 when converted is 24,000. then 28 converted is 28,000, and 26 converted is 26,000. So what we're going to be getting from there, when we combine all of them and then divide by 4, we get 2.5 times 10 to the 4. So in this case, only 2 of these fall, so these 2 are within our category, or within our range, and then only 1 of these is within the range. But since 1 of the 2, we need to use all 4 numbers, okay? So if the higher diluted set of plates is more than twice the count of the lower set, then you only use the count for the lower set, the less diluted set, okay? So in this case, since the difference between these numbers is 2.5 times higher, right? So 13,800 and 16,200 are quite a bit bigger than these two, then we don't want to be using these, because there's a lot higher chance that they're going to be have error involved with these numbers since they're lower. So then we're going to be using this larger numbers, which are less diluted, right? Because the numbers are bigger because we've diluted it less times. So for rule number 5, if none of the consecutive dilutions yield 25 to 250, then you're going to be using the count from the more concentrated set. So the more concentrated or less diluted. And for this, since none of them fall within our range, our 25 to 250, then it's going to be an EAPC, which is an estimated aerobic plate count, okay? So keep that in mind. There's a few situations where we can only get the EAPC. So if none of our plates are within our countable ranges, then it's only going to be EAPC. So number 6, if all the plates have less than 25, you take the set that is closest to 25 CFU. So here we have our 2 dilutions, 10 to the negative 2, 10 to the negative 3. Then we have 18 and 16, and 2 and 0. So 18 and 16 are a lot closer to 25. So then we take these numbers, take the average, and then that's our estimated aerobic plate count, or it's just less than 2.5 times 10 to the 3. So if all plates have more than 250 colonies, use the plates that are nearest to 250 counts. Okay, highest dilution. So report that as greater than 250 times the highest dilution. So here we have 10 to the negative 2 is TNTC, TNTC. Then here we have 380 and 400. You take the average of those, you get 3.9 times 10 to the 5 EAPC. Or this is just greater than 2.5 times 10 to the 5 EAPC, right? Because it's above 250. So now for to take a look at a few of these. So for this example, we only have one of these dilution factors that is within our countable range. So we have 240 and 210, whereas we find that the 10 to the negative 2 and 10 to the negative 4 are either too high or too low to be countable. So we're just going to be working with this middle 10 to the negative 3 dilution factor. So if we were to take the average of these, if we combine them, we get 450, and then you divide that by 2, and then you get 225. And then we need to make sure to round this to do 2 numbers, right? 2 significant figures. So then that 2.25 times 10 to the 5 turns into, rounds down to make this even, to make it 2.2 times 10 to the 5. Now for this one, again, we only have one dilution factor that's within the countable range. This is 10 to the negative 2, since it has 250, but only one of the 2 is within the countable range, but we're still going to be using both of them at this dilution factor, since one of them is within the range. That's according to rule 2, okay? So you add those together, take the average, and then calculate the CFU per ml. Now for this one, we have 280 and 300, 1035 SPR. So this is a spread plate, right? So we can't count that one. Now for this example, none of them fall within our countable range. So we're going to be using the ones that are the closest to 250, right, according to rule number 7. And this is going to be an estimated aerobic plate count, all right? Estimated. And then for this one, 22 falls within our range, and 240 falls within our range. So if that's the case, we have to use all 4 of these numbers, add all 4 of them, and then take the average, and that's your plate count, okay? So we can figure out how to do this for this last problem. So we have 280, right? And this is times 10 to the negative 2. So this would actually be, we would have 2, okay. So then if we were to convert this to 280, then that would be 28000, right? So we're going to add 2 zeros because this number here is 2. And then that would be plus 240, and then additional 2 zeros because of our dilution factor. Now, let's add our third number. So this is going to be the 22 times 10 to the negative third, so that's going to give us 22,000 plus now 28, and we do 3 zeros, so we get 28,000. So we add up all these numbers, and then we divide that by 4, and that's going to give us our average. And then we need to make sure that there's only 2 significant figures. 2.6 times 10 to the 4. CFU per ml is our answer then. Okay. So for the Petri film method, make sure you know that the colonies are stained red, and you're going to be counting all those colonies if you're to do that method. Then for SimPlate method, our positive wells are going to be pink, or any color that is not blue, so blue would be negative. And then you'd count those positive wells, and then you'd calculate the most probable number, the MPN, using the table provided. So if you know the dilution factor, then you can figure out the number of most probable numbers per ml. Okay, so this is the table I was just talking about. So, for example, if you had 5 positive wells, 5 pink wells, then you would have a most probable number of 10. Okay, so just a statistical estimation of the amount of bacteria in your sample. Okay, so for lab 3, sauerkraut fermentation, it's important I want you all to watch the video that I posted on Blackboard and follow those directions. Make sure if you haven't bought all the supplies and the cabbage that now is the time you get it, so you can be ready for that. Make sure that you complete your fermentation and make your posts on the discussion board by Sunday, okay? So lactic acid bacteria, these are going to be the ones that are responsible for our fermentation. So these are known as labs or lactics. So they're going to have a lot of characteristics that describe this group. So they're going to be gram-positive. They're going to be catalase negative, so they will not produce catalase. They do not have cytochromes. And then they do not, they are going to perform lactic acid as a major end product, okay? So most bacteria are not going to be producing lactic acid, and kind of as the name implies, that is what makes these bacteria special, is their ability to create this acid and then survive in those conditions, okay? So another thing that they're going to produce are known as bacteriocins, which are antimicrobial peptides, okay? So, lactic acid bacteria have been used to ferment foods for at least 4,000 years. They've been used for a long time by society. And they can produce acid, right? We're talking about lactic acid specifically. And then they can survive in these conditions below 4 pH, which is very special. Typically, bacteria cannot survive in those conditions. So this allows for you to select for lactic acid bacteria in your dish or in your fermentation, because since the pH is getting reduced by the lactic acid, only certain organisms, such as lactic acid bacteria, will be able to survive. Okay, so which of these is not a product of lactic acid bacteria fermentation? Kimchi, sauerkraut, kefir, yogurt, or tofu. And this is a trick question. All of these are going to be produced by lactic acid bacteria, so make sure you know that. And then lactic acid bacteria are very beneficial because they're also going to be used as a probiotic. So they're going to be inside of our digestive system, and they're going to assist in our digestion. Okay? So, sauerkraut fermentation has been used a long time. It actually means sour cabbage. And so it's originated in China, and it's thought to be introduced to Europe in the course of raids by Genghis Khan in the 13th century. And sauerkraut is a rich source of vitamin C, and since it can survive since it's fermented and can be stored for long times, then this is a perfect dish to take for sailors, because typically the fruits that are a high source of vitamin C are going to perish and not be able to survive a long journey that sailors would typically be taking. So, sauerkraut was a really popular dish for sailors and pirates because of its ability to prevent scurvy, okay? Which was a pretty bad disease for them, since they weren't able to have a lot of the fruits and vegetables we have. So, we have two major genera, Leuconostoc and Lactobacillus. Okay, those are going to be the two that are primarily responsible for the fermentation of our sauerkraut, okay? So, in the lab, how I'd be testing this sauerkraut. So after preparing it, we would be performing a titration of lactic acid in the sauerkraut. So we'd be testing using NaOH and just your typical titration. But since we are not in a lab for this, you're going to be using the pH strips that I told you to order in the syllabus. You'll be using those to test your pH of your sauerkraut every week. So make sure to do that right now when you first create your sauerkraut. When you first create it, test the pH, so then you can see the pH change as the fermentation progresses. So you'll be writing about that in your discussion board. And then so we would also be performing plate counts, so the APC. We would be using TSA plates for that, okay? And then we would also be detecting slime-forming lactics. In order to do that, we would be using SGA, okay? And then for detecting gram-negative bacteria, we would be using EMB agar, okay? So we'll be talking a little bit more about all those next week. Just make sure you know what we would use to test for these different things. So aerobic bacteria would be TSA, slime-forming lactics would be SGA, and then gram-negative bacteria are EMB. Okay, so if you have any questions, feel free to message me. Make sure that you have your sauerkraut completed by at least Sunday so you can do this discussion board, which requires you to make your sauerkraut and get it done in order for you to answer some of those questions. So, good luck with that. If you have any questions, let me know. See you next week.